Hello, chemistry students. Today we are going to talk about combining matter. And by the end of this video, you should be able to use oxidation numbers to determine the number of atoms that should be on the right-hand side of a chemical formula. Let's go over a little vocabulary. When you're reading chemical formulas, there's always some elements or molecules on the left and then some on the right. The elements you see on the left are always going to be called reactants. And on the right, you have the products. In this example, I have two reactants combining to form one product, but there are many other different combinations, and we'll go over all of them in semester 2. But right now, all I want you to remember is on the left, you'll see reactants, and on the right are the products. So for example, we have the reactants sodium and chlorine, which combine to form a product, sodium chloride. Okay, for this exercise, I want you guys to have your periodic table of the elements handy, and we're going to use that to combine these reactants into products, and we're going to do that using oxidation number. These are ionic molecules, so what they're actually going to form is ionic molecules, and those molecules always have a neutral charge. So calcium and sulfur will combine in a way where its product has a neutral charge. And in order to find the neutral charge, you first need to find the oxidation numbers of calcium and sulfur. Calcium is a group 2 element, so its charge is +2, and sulfur is a group 6 element, so its charge is -2. So we need to figure out how many calcium atoms and how many sulfur atoms to combine in order to get a neutral charge. Now this one looks like it's a pretty easy answer. You can see, I can see, 1 calcium equals the charge of 1 sulfur, so the final answer is CaS, but I want you to learn the crisscross or drop and cross method for figuring this out, because not all of the questions will be this simple. So the charge of calcium is +2. You're going to cross that charge down and put it as sulfur's subscript on the product side. So you're going to put a 2 here. And then this charge gets crossed down and put there. Once you have the 2 subscripts, you find the lowest whole number ratio, because you can't split an atom in half and have it be the same element. So you have to have a whole sulfur atom and a whole calcium atom. You can see that 2 and 2 split off, and then the answer is Ca1S1. But you and I both know that in chemistry, you don't put ones, you'll just leave it off. So the final answer is CaS. Next we have strontium and selenium. We need to figure out how many of each will make a neutral molecule. Strontium has a charge of +2. Selenium has a charge of -2. We're going to use the drop and cross method. And then reduce it to the lowest whole number ratio, which is 1:1, meaning that our final answer is SRSE, is a neutral molecule. Now we have potassium and tellurium. Potassium is a group 1 element. And tellurium is another group 6 element with a charge of -2. So we drop it across those charges. Okay, so this is telling me that I need 2 potassium atoms for every tellurium atom in order to form a neutral molecule. And you can check that by multiplying the number of atoms times the charge. So it would be 2 times +1 equals +2. And then on this side, it's 1 times -2 equals -2. So those two charges are equal and opposite, meaning that our molecule will be neutral. So you'd write the final answer this way, K2TE. Okay, our last example is rubidium and phosphorus. Rubidium is a group 1 element, so it has a charge of +1. Phosphorus is a group 3 element with a charge, a group 5 element with a charge of -3. So we will drop and cross those charges in order to figure out the ratio for the neutral molecule. So it's 3-to-1 ratio. That cannot be reduced and still have a whole number. So the final answer is Rb3P. Now you can use that same strategy to figure out the oxidation number of unknown ions. There are 2 kinds of ions. There are monatomic ions, which is what we've been studying up to this point, and those ions have just one atom, but there are also polyatomic ions. So they stay together as a group and they work together, but there's more than one atom in the ion. And this slide actually has several polyatomic ions. So this one, that's a polyatomic ion. Here's another one. And there's another one. So those work as an ion, and you can see that they're all anions. They all have a negative charge. So what we're going to do is figure out the charges on the highlighted atoms. Okay? They're all kind of different. And the other thing we're going to do is we're going to figure out how many atoms are in the molecule. So we're going to do charge, and then number of atoms. Okay. And it's the charge of the one that's highlighted in blue. The first example, we have ruthenium and sulfur. Okay, sulfur is a known element, and it's a group 5 element, so we know that it's a group 6 element, so the charge on it is -2. The charge is -2, and there are 3 of them, so the overall charge of sulfur in this molecule is -2 times 3, -6. So all of these ruthenium molecules need to add up to a charge of +6, because we know that this molecule has to be neutral. Okay, so you would take +6 and divide that by the number of atoms, which is 2. So the charge on each of these is positive 3. And then the total number of atoms, you just add those up. So that's 2 plus 3. There are 5. Okay, the next one. Here's our polyatomic ion, and we want to know the charge on that guy. And you can actually use your periodic table to figure that out. Rhodium is a transition metal, so we don't know his oxidation number because we know that the transition metals can play some tricks sometimes. But if you zoom into your on this periodic table, you'll see that this periodic table actually gives common oxidation numbers right here. And rhodium, luckily, only has 1 that it makes, and it's positive 3. So, going back over here, we know that the charge on this is positive 3. And there is only 1 rhodium, so the entire charge on the polyatomic ion, which there is only 1 of, has to be equal and opposite to the charge on rhodium. So the charge on this one is negative 3. The number of atoms here are 1 rhodium plus 2 carbons, 6 hydrogens, and 2 oxygens. So that is 3, 9 plus 2, that's 11 atoms. Okay. On this one, I have included a common polyatomic ion. You will memorize this soon, or I will give you a chart to get it from, but I will tell you this time the charge on SO4 is always -2. So this outside the parentheses tells you that there are 2 SO4 anions, and each of them have a charge of -2, so the overall charge on this side of the molecule is -4. There is only 1 manganese atom in this molecule, so its charge has to be equal and opposite to SO4, so its charge is +4. Okay, now we're going to figure out the number of atoms in this molecule, and this part is a little trickier, so I'm going to go ahead and erase everything else on here so I can show you that there are 2 SO4 anions. So what you need to do is multiply everything inside the parentheses by 2. So there are actually 2 sulfurs and 8 oxygens total. So it would be 8 plus 2, which is 10, plus 1. So there are 11 here. Okay, finally, ZnO3, a polyatomic anion, but I do not know the charge of this one. It's not a commonly found anion, but we can calculate the charge on it using potassium, which is a group 1 element. We know that potassium has a charge of +1, and there are 2 of them. So the overall charge on the positive side of the molecule is +2. So the charge of ZnO3 must be -2. And there are no parentheses here, so we don't have to multiply anything through. We can just add up all the subscripts. There are 2 plus 1 plus 3, which is equal to 6 atoms.